Hi, this is a brief video to go over some slides that we didn't quite get to in class, but I thought I'd share with you online. I'd like to consider this position as a function of time graph, where we have a linearly increasing position, and ask what is the velocity of this object being indicated here. And I guess we use our constant velocity model because it is a linear position as a function of time. Constant velocity math model is delta x equals v delta t, or the change in position is equal to the velocity times the elapsed time. That's the same mathematically as saying the velocity is the rise over the run. That's 6 meters divided by 2 seconds, so that's 3 meters per second. That is the velocity of this object being indicated here. Now let me ask you this. What is the velocity of this object being indicated? Well, it's a bad question, isn't it? Because at different instants, there are different instantaneous velocities. We know that velocity is the derivative of the position function. Here, if we were to imagine a tangent line to the function, it would have quite a low slope. Here, if we were to imagine a tangent line to the position function, it would have a higher slope. The slope of these tangent lines is the value of the velocity at those different instants, and the slope of those lines is changing. The velocity of this object is changing, just like the fan cart that we saw. So if I ask, what is the velocity? That's a bad question because there are different instantaneous velocities. I could ask a different question, and that is to ask, what is the average velocity of this object between 0 and 2 seconds? That is an answerable question. What's up with average? I guess when I ask what the average is, it's like saying, well, yeah, the velocity of this changes, but if it had been going at just one velocity the whole time, what would that velocity have been to sort of have the same effect as this changing velocity? See how there's the same displacement, 6 meters, with this changing velocity as if this blue average velocity had been the velocity of the object the whole time. In other words, the average velocity is the slope of that blue line. The average velocity is the displacement divided by the elapsed time, and those angle brackets mean average. This is average velocity, displacement divided by elapsed time. In this case, that's 3 meters per second. Recall we'd already talked about speed, and speed at any instant of an object is the absolute value of the object's velocity. I'm going to ask you this question. Consider this position as a function of time graph, and can you tell me what the average velocity is, and can you tell me what the average speed is? You might want to pause the video and see if you can do this. Well, the average velocity, as we saw, is the displacement over the whole interval divided by the time interval. And let's see, this object starts at 0 meters of position and ends at minus 3 meters of position. Its displacement is minus 3 meters, minus 3 minus 0. And that occurred over 6 seconds, so there's a velocity, an average velocity of 0.5 meters per second. What was the average speed? Well, for the average speed, you can find the average speed by the distance traveled divided by the elapsed time. And remember, distance traveled is the sort of shoe leather distance, the sum of like the absolute value of all of the little steps. Distance traveled only ever increases. So if I want the average speed here, I'm going to have to think about this distance, which is 6 meters, that distance, which is 0, that distance, which is again 6 meters of distance traveled, and that distance, which is 3 meters of distance traveled. So I guess that's 15 meters of distance traveled over 6 seconds. That's 2.5 meters per second. And now, just to close a thought in our acceleration slide, just as average velocity is displacement divided by the time interval, average velocity is delta x over delta t, what's average acceleration going to be? You might want to pause the video. The the average acceleration during a time interval is the change in velocity of an object divided by the change in time.